Which finally brings us to this blockchain technology. And as this data is created, you have to remember there's a GPS point for literally every nanosecond of every time. Like it exists, just like the thing on a straight line. Like how many points are on a straight line? Infinite, all of them, right? All of them. And so this data can be recorded. So we use machine learning to kind of sift through what is and isn't necessary. But big data is an issue, and it's only going to get bigger because now we're collecting more data and having to put that into the machine learning because the machine learning now needs something else to eat or play with as it's trying to figure this thing out. Which brings me to the end. I'm working with a guy in Arizona, and we have come up with this kind of use case scenario for blockchain technology in agricultural systems and environmental sciences. So he's an environmental scientist in Arizona, and he basically goes out and makes sure that the gas stations are in compliance, and then also does some other environmental stuff and making sure that those conservation practices are being met. So the problem with that is it does need to be incentivized. And so as we start telling producers to change into doing these climate smart agriculture and start doing this conservation practices and soil health and carbon sequestration, how do you monitor that? How are you going to tell a producer they need to monitor how much carbon dioxide they are or are not emitting?
You just have to monitor it, but getting them to let you monitor it is the trick, I would imagine.
It would be.
They don't want you.
They don't want you there, right? And they don't want to do it because then they don't want to know. It's kind of like checking your bank account. I don't like checking my bank account because I don't want to see how much money I spent. I don't want to see that I'm not meeting the standard. How do you really verify that someone sprayed less Roundup this year? How would you compare them?
You gotta either trust them to just tell you.
And of course they're gonna lie because there's money involved.
That's why I work with animals.
Right. So like of course they're gonna, like keeping that data is a pain in the neck. Like I got other things to be worried about other than monitoring Joe Bob, who's I'm paying $10 an hour to go spray weeds with, right? Like driving a tractor or whatever. So I believe that we can use this precision agriculture and the technology that we have for these monitors to determine how much we actually applied. And we also want to minimize the application, so we don't want this big 60-foot boom sprayer going across the field for 17 weeks. So we can use these sensors to monitor our fertilizer use, and remember that if we don't have a plant there, we can use that technology and it doesn't apply that nitrogen. So less fertilizer use, going to lead to some benefit economically, but also that we didn't apply as much. All right, this thing's super cool. I hope this plays. Come on. Quick little 2-minute video. Notice that it's just dropping the fertilizer where it needs to. So there's been some movement through the field, or at least the sensor on the front of that rope, like see the sensor at the top? It is shooting X feet in front of it and recognizing where a weed is or isn't. That data is being processed instantly. And by the time that tractor gets, or this little robot gets to that destination based on the GPS, it drops the exact amount of fertilizer necessary to kill that one plant. Compared to this. So not only is that economically advantageous, but also in this conservation practice. So this thing is obviously already on the market. Self-driving tractor, automatic sprayer, knows the difference between the peppers and the weeds, and we're using machine learning and deep learning models to determine that. We have Eden Library that knows the difference in the plants, allowing it to learn and improve as it operates. Of course, the pesticide industry is going to be upset about this. They're about to lose 90% of their profit. All right, cool. So here we have this thing, this robot that is traveling through the field that can detect where the weed is. Thanks. Gotcha. Move forward. Nope. About that. All right, cool. So we have this, now we have this robot that's running itself, or this tractor that's driving itself, that has a sensor on it that monitors the output of herbicide. So that's how we monitor on whether or not you actually decreased your use. Additionally, because that sensor picked that data up, it knows next year where that weed should or should not be. So now we can actually analyze on whether or not that particular herbicide was effective against mitigating weed pressure in your field. Man, that's super freaking awesome. Now I don't have to do this. And so now we have this one person that's monitoring their irrigation and their spraying and their harvesting and all this other stuff. And it's being actually recorded on the blockchain. And once it's recorded on the blockchain is basically a group of servers in the computer across the globe that all verify that this data exists. So it's very difficult to get into that blockchain and change the data at these different nodes. Right? It's just it's a checks and balances to make sure that everything is still accurate. So we've got these sensors, we've got the data collection, we got blockchain technology. And what I believe we can do, you write a smart contract that has these certain conservation criteria. You have to meet criteria 1, 2, 3, and 4. And when it is, you are issued a non-fungible token. My NFT thing, but it does have application. So the problem is that we have anonymity, and we don't want that data to be known that it's that person. So how many baseball players have we had throughout time? And you can do that by state. Let's say you live in Missouri and you're a Kansas City Royals fan. You sign up for the Kansas City Royals NFT collection, and every NFT, every baseball card, or every baseball player that ever played for the Kansas City Royals, that can be your identifier, and that's the NFT that you get delivered. So that when each one of these smart contracts is these conservation practices is met, you get issued an NFT. So you do that over 4 years. You got NFT 1 that measured that you decreased your herbicide use and your fertilizer. You get NFT 2, 3, and 4. And then when you collect all 4 NFTs that you've met all the conditions of the smart contract, that money is instantly sent to your wallet or bank account. So now there's not this, well, we have to come audit your records. And you got all these books that you have to put on the table and let the NRCS person come through. It takes them forever. And then they're gonna find some discrepancy because that's their job, is to not pay you. But you did everything you were supposed to, and now it's documented. And they can't, and now they don't have to. So once that smart contract is met, boom, the money gets deposited in your account, and that's how we can incentivize that and make it not a hassle for both parties. I believe this thing is going to be huge for the future workforce because they're fiercely independent, even though they don't really know what they're doing. They want to do it, but they don't know how to do it. They also don't want to actually do the work, so they'll find the easier, softer way. They're technologically challenged. The number one thing I hear from students tell me is that they're not good at math and they're not good with technology. What am I supposed to do with that? Like, do you understand that's what we do? Is technology and math. You got to add your money up. So I believe this is going to be a challenge. And when I gave this presentation previously, I went through that, like, we need to start at at the elementary level and get them at least learning what coding can do. And then as you move up into middle school, you increase the level, and now they're dealing with greenhouses through a VR headset. And then as they get to be high school, we're preparing them to come to college, where we're gonna teach them how to operate the robot that's spraying the fertilizer, spraying the herbicide. So this is my job. My job is to make sure that the person who leaves as an agronomist has an understanding of these technologies at bare minimum, because if you don't understand the technology, then it's pointless. So trying to teach them the technology first, but then also that they need to understand some of the back story, the fundamentals of agricultural production is important as well. But like, they need to be knowing the technology more than they need to be knowing the backstory. We can Google that. You can ask Grandpa, he'll tell you the backstory, but you're gonna need an hour or two. And again, cannot hire people and tell them what to do from two standpoints. Number one, we hired you, you should know. That's my biggest one, is like, I don't want to send students out that don't know, that have to be told what to do and have their hand held because they don't know, and they get to their job and they made it through Tennessee Tech and they've got their degree, and then they go, I don't know what I'm doing. You're like, why do we hire you then? And then also we would hope that they're smart enough that someone would go, you know what? You are way smarter than me at machine learning and K-nearest neighbor and randomized forest, and I'm just gonna let you handle that business. And trust that you know what you're doing, and just that I know what I'm doing. And so that is all I have for that. About an hour.